Okay, thank you for joining this session. I'm going to talk about an experimental search project, Liferay GSearch. I started almost exactly 2 years ago. So first I'm going to talk about the background and motivation for this project. I'll have 2 demo cases, and then briefly about the implementation, architecture, configuration, and lastly some observations and lessons learned during this project. Starting as a simple search portlet experiment with some auto-completion features and still to be considered as experimental, this project has up to this date become an application suite or framework consisting of 17 modules, and it has actually been taken to some live production systems too. It has a reusable engine allowing to configure practically all the aspects of search query in context-aware way. It has search and recommender portlets, integrations to geolocation and weather services, as well to Liferay segments and analytics cloud. It also features natural language processing and machine learning in the background. But what is this project trying to do or solve? It's about Google. So I'm showing here 3 Google search result listings. They are using the same keywords, same machine, same browser, but getting different results. Because the first query is done from Finland, second from Mexico, and the third from Japan. Another example, these 2 different listings are using the same setup and using even the same location. But the first one is done while logged in to Google, and the second one is done in private session and not logged in. So it's obvious that those great search results Google provides depend a lot on the context. And it's no wonder that context has to matter. So if you think about the word play from previous example, it has about 100 meanings in Merriam-Webster's, not to talk about varying connotations and meanings in different locations, countries, and cultures. And it's search engine's challenging task to try to figure out what the user is actually meaning with the keywords. So Google does it great, and the primary motivation for this project was to figure out whether something similar, something Google-like, could be created on Liferay. The Google likeness was all about user experience or search experience. So on the other hand, about the user interface, but more importantly and specifically about the personalization and relevance. If we take a look at the definition of relevance, it says nothing about keyword matching or scoring algorithms, whatever, but it's about meeting and satisfying the information need of a user. It's about personal experience, which is not only context like time and date, time and place dependent, but can completely differ from other users' experience. So I believe that to make sure results really matter to us, we need some kind of personalization. I knew Liferay would be a great platform to build this kind of search because it can provide a lot of contextual information out of the box and can easily integrate to external systems. So I started to parse this idea and came down to the requirements for this project. The search experience has to be personalizable. If I, for example, search for a cafe, in some use cases, in some domains, I could like to get the results in the way Google does it, using my location and possibly using user rankings to bring the cool places close to my location to the top of the list. The user interface should be fast, simple, have keyword suggestions, type ahead functionality like Google, and configurability. So this application should be easily configurable and foremost adjustable to adapt to different domains and use cases. There should be no deploy process involved. I had also 2 non-functional requirements when starting. It should be done as Liferay natively as possible. It should not break any core functionalities. And the application design should be modular and extensible. So let's see first in practice what came out of it, then about the implementation. So I have here 2 demo cases using regular keyword matching techniques for finding the documents. But then different kind of personalization features of this application are used to enhance scoring to better suit the use case. And in the second demo, we also use machine learning. This first simple demo case is about finding information about restaurants close to my location. I'm using just a single keyword, restaurant, and the goal of this exercise is that information about restaurants close to my location should appear on the top of the list. My test user here is an unauthenticated user and located in Helsinki, and we are using that information. My test data here is about 1,000 imported, unmodified articles from Wikipedia, using those page scrolling routes there. And features I'm using for personalization here is natural language processing to extract places data from the contents. I'm using geolocation to extract users' location data. And then I'm just simply giving some extra boost to the documents where users' location data matches with contents location data. For baselining, let's first see how it works with the Liferay standard search with no customizations or tunings whatever applied. So I'm here entering restaurant in the standard search bar and getting 729 results. Restaurants from Mexico, Lagos, Australia. And the first restaurant in Helsinki, what I'm interested in, is on page 18 at place 358. As it's called Chez Dominique. So let's see if we could improve that with personalization. The Liferay GSearch now. I'm entering restaurant, and restaurants in Helsinki are on the top of the list, Chez Dominique at place 2. How about if I was in Stockholm, in Sweden, using the same configuration, same setup? I'd get Swedish restaurants located in Stockholm. Or if I was in Paris, France, I'd have Parisian restaurants. Okay, so the next demo case is a bit more complex. I'm here simulating search experience in a web shop. So there is a customer searching for jackets, and we use context awareness and personalization to make good guesses what this person might be looking for. I'm again using just a single keyword, jacket, and my goal is that jackets relevant to my location, profile, preferences, user segments, being popular and available in my country should appear on the top of the results list. My test user this time is an authenticated user, having his gender and age in the profile. He's located again in Helsinki, Finland, having winter there, and he has been using color red frequently in previous searches. So we are using that data for personalization. And this guy belongs to interested in hiking user segment, which could be done on Analytics Cloud. My test data here, unfortunately, I didn't have Liferay e-commerce for 7.2 available, so I had to improvise this thing, but I'm having 60 jacket products. They are identical in content, but strongly categorized. 24 women, 24 children, and 24 men. And there I'm using some subcategories to be able to narrow down the search. And features used for personalization in this exercise. I'm again using geolocation to get user's location. I'm using weather service to get season at user's location. I'm using users' gender and age, users' Liferay segments, and machine learning. So I'm using click tracking to find out highest ranked results. And I'm using previous queries and natural language processing to extract data from previous queries. And expected top results based on this are here. So results titled men's winter jacket 1 to 4. Again, let's baseline the demo with the uncustomized standard search portlet. See how it works by default. Okay, I'm getting 60 results as expected. And the men's winter jacket would in this case be on page 2 at place 21. And next I'm doing that with Liferay GSearch, and I'm first doing the search unauthenticated and all the personalization features switch off. After I log in, these features come into play and we'll see the difference. Okay, so first unauthenticated. I'm getting men's winter jacket at place 7. Yep. And then I'm going to log in. Now my personalization features are in use, and one thing to do is to refresh the search results. And the top results are exactly what I expected. Okay, so about the implementation and architecture briefly. The key components of this implementation. So first I needed a custom Liferay Elasticsearch adapter because the standard one was missing some features. I needed to customize index settings, like add new mappings, enhance analysis, create new analyzers. Then I needed some custom query translators. These components take care of translating the Liferay Search API queries to search engine native queries. And they were missing some features in standard implementation. And lastly, I needed to enhance the custom keyword search system. The second key point was Ajax user interface. The first implementation was done with Google Soy and Metal.js, but Soy being deprecated more or less, I moved to React with 7.2 upgrade. And the third thing is this dynamic query building engine. So this engine was built so that I could exactly control, depending on the context, which clauses should or should not be added to the main query. So for example, I wanted it to be possible to add a clause, let's say only if user is in Finland and not member of group X, etc., etc. How about the architecture? So for the reference, here's the Liferay Search Framework standard architecture. Search portlets there communicate with Portal Search API, which together with Portal Search SPI form the implementation specification for Portal Search layer. And below that we have the Search Engine Adapter API, which is practically the lowest level you can access as developer. Liferay GSearch adds their few layers. So in this implementation, the portlet is called the Liferay GSearch core API, which is built on top of extended Portal Search stack. And on the bottom, you have set there the custom Elasticsearch adapter implementation. The search requests in this implementation are done by calling directly the low-level Search Engine Adapter API. More closely, what happens after entering the keywords and before getting the results? So because of modular design, there is a number of processing layers here. So when request comes in, either from UI or REST API, query context is first being built. Then query context contributors are processed. These are practically components making any kind of contextual information available for all the other layers, like for query builders. And out of the box, I have the contributors for user properties, geolocation data, weather, Liferay segments and analytics cloud data, and natural language processing. At next step, the parameters are being validated and parsed from request. Filter clauses are being built based on the configuration, on the exact configuration. And at next step, the search clauses are being built. There are clause condition handlers, which basically check whether a certain clause should be applied or not, or injected. And the clause builders take care of building the actual search clauses. With query contributors, you can manipulate the query even more complex ways. Aggregations are built, and then we shoot the request to search engine. And after getting response, there are 3 layers. The result item builders, they take care of transforming the index documents to result items. And we have few processors there more. And we get the result. Configuration. This application is all about configuring and configuration, and there are quite a few options available. I'll now explain just how the most important single configuration, the search clause configuration, works. But a few basics before going there. So what the user and search engine communicate with is the search query. So it's basically like a question, like, do you have anything titled Liferay? And query usually consists of multiple clauses, basically subqueries, which can, depending on the run context, be filter clauses, search clauses, or rescore clauses. And filter clauses are just to narrow down your question, and rescoring is getting a better order for your results, so to say. And here's an example of a query having 4 subclauses or subclauses. The blue ones here are filter clauses, just narrowing down the search. So to company ID 20112, entry class name, let's say journal article, status 0, which equals to published. And the green one here is your actual question. Is there anything titled Liferay? One of the core ideas in this project was that we could exactly control and configure the building of all these clauses, filter, search, and rescore clauses. And the search clause configuration consists of JSON configuration items here, and each of them capable of having an array of conditions and clauses. For example, conditions in a single configuration item could require, as mentioned before, that user belongs to a certain user segment, is located somewhere, maybe member of a group, this and that. And if these conditions are passed, then the array of clauses is injected to the query. And there can be any number of these items. So in this clause condition example, user's location has to match Helsinki or London. In just a single condition in this example. And here's an example of configuration items clauses array. And this particular clause gives a boost of 10 for wiki page asset types. And we can also use context variables in the configuration. So in this example, the clause is targeted to localized content field, and it's using user's job title as value. And here are some of the available context variables. There are quite a few more. Okay, so how does it look in practice? Let's do a live demo here. So here I have the setup from the first demo case. Restaurants, I'm having a list like this, no personalization used, and I'd like to enable the personalization here. So I have my configuration in control panel, system settings, Liferay GSearch. And first, let's check the geolocation module here. I'm using an IP address in Helsinki as this address. And here are my configuration items for search clauses. I'm interested in the last one here. Let's expand that a bit. So here I have my condition, which basically says that user has to be logged in. And here are my personalization clauses. The only thing to do here is pre-configured now. I just put that to enabled. True, update, and let's update the results. And now I'm getting localized contents, or contents having to do with Finland, Helsinki. Okay. Oh, please excuse me. Yep. Okay, then about lessons learned during this project. There are definitely better and worse suitable configurations for different environments, but I think there is no single right or wrong one. So for example, at universities, people would probably prefer results precision over recall and would probably appreciate content quality over, let's say, content proximity. If you don't have sufficient amount of metadata and of sufficient quality, it will be hard to personalize results. And tagging and categorizing here is our friend, I think. Whether you do it with the means of AI or manually or combined, it doesn't matter, but have metadata. There's no magic, at least I think so, in creating good search configuration. Define requirements, try to understand the expectation in the domain, create enough example queries, try and make mistakes, and take time to make it all work in a satisfying way. That's the way I think about it. Maintaining configuration, that's a big issue, I think. So data evolves, trends change with the time. Scoring configuration and, let's say, machine learning-based rankings, they need to be maintained too. So let's think about clothes or fashion as an example. And let's say you have a learning to rank system and judgment list there saying or implying that red trousers are the hottest hot for this season. Next season, that most probably won't be true anymore. Configuration need maintaining. In configuring, I think it's important to find balance between doing too little and too much. So some compromises between personalization and generalization might have to be done. And also to think that complex queries, let's say if you use script queries, they eat quite a lot of computing time and execution time. And at a certain point, you might have to decide whether to have faster or more relevant search. Use explain. I have to make confession that I really learned to use this tool with this project, not before. So when tuning your queries, no matter if using this application or standard search or whatever application you have, use this explain functionality provided by the search engines. It shows you exactly how the exact individual clauses affect your actual outcome there. And the results there might surprise sometimes. Relevancy, I think it's about personal experience. Use A/B testing and real users if just possible. And GDPR, be careful with what and how you collect and use personalized information. And even if it was just cookies, there are things to know as I expect you everybody know here. And that's pretty much it. You can find the project source codes in GitHub at this address. And the demo configurations are also available. The documentation there is not extensive really, but I've tried to provide enough example configurations to get started with it. And I think we have a few minutes for Q&A if there are any questions.
For which version we can use the GSearch? Only Liferay 7.2? Or there are possibilities to use it in 7.0 or 7.1?
So the question if there are versions for 7.1 or 7.2. Yeah, so there are versions from 7.0 to 7.2, but let's say that the 7.2 is far more sophisticated than the previous versions now. So if there's demand, and if I have spare time, I can backport that to 7.1. Well, sure.
Thank you.
And I have to say one more thing, that they are quite strictly bound to certain fixed packs and service packs, so they might not work with everything. Search API is evolving quite fast nowadays. But let's be in contact with me and we can find out if you are interested.
I have a next question. Thank you for the presentation. Is there some institutional support behind, or what are your plans on maintaining this feature for the future? So if we would, for example, use it in the project, we would like to hear that there is planned some, future of that it will not be forgotten in the future versions. So do you have some ideas on this? How will you maintain this in the future?
I heard pretty badly, but was it like about the future of this project, if you take that?
Yes. What are your plans, actually?
Long answer is I don't have anything right now. But as said, if there's like demand, this is a hobby project. I love doing this, and if I can serve you in some way with this, I'd be happy to maintain it. But there's no official support. This is a personal project.